In this video, we're going to look at permutations of R objects from N objects. So this first question says, how many three-digit numbers can be formed from the digits 1, 2, 3, 4, 5, 6, and 7, using each digit at most once? We'll start by just thinking about your options. For your first digit, you've got 7 options. Now that you've picked a digit, you only have 6 options left for your next one. So you've got 6 options for your next, and then once you've picked that, you've got 5 objects for your next one. So that's the number of different three-digit numbers that can be formed. 7 times 6 times 5, or 210. Now, this actually has its own function called the permutation function. And so the definition of NPR is, well, let's build it up from this. In this case, we had 7 times 6 times 5, and that's because it was 7 and we were picking 3. So in general, if you have N and you want to select R from those, where the order matters as it does here, we're going to have N times N minus 1 times N minus 2, etc. And we're going to keep going until we've selected R objects. Now, a neat way of representing this is as follows. We're going to, again, start by looking at this case here. 7 times 6 times 5 can be represented like this. Suppose, and you'll see why we do this later on, suppose I wrote down 7 times 6 times 5 times 4 times 3 times 2 times 1, but then I wanted to clear out all of the numbers up to 4. So I'm clearing out 4 times 3 times 2 times 1. Well, what is that? That's 7 factorial divided by 4 factorial. How can we generalize that here? Well, the 7 was our n, so we have n factorial. And then what was the relationship between this 4 and the fact that we were looking for 3 digits? Well, that's just 7 minus 3. So we're actually dividing by n minus r factorial. And this is the p function, or the permutation function. And there's going to be a button on your calculator for that. For instance, if you're using this calculator here, we would just go for 7, I go for shift, and then this times button, P, 7P3, and I get the 210. Okay, how about this one? The letters A, B, C, D, E, F, and G are written on 7 tiles. How many arrangements of 3 letters can there be that begin with the letter A or include the letter A? Well, if it begins with the letter A, well, that's not really a decision, right? That's done. So you've got A already. And then what follows? Well, I just need 2 more letters. And so I have, well, there is 1, 2, 3, 4, 5, 6, 7. There are 7 letters, but I've already picked one. So there are 6 letters that remain. So I've got 6 choices for my first and 5 choices for my second, which is 30. If you wanted to use the P function here, it would be 6P2. 6P2 is 30, and that's because I had to choose or pick 2 of the letters from the remaining 6. What about one that begins with the letter A? Well, sorry, that includes the letter A. Well, if it includes the letter A, it's either because it's the first letter, the second, or the third. So we could just take any of the options that we had before, but just change where A was in that group, right? Because let's say that one of the solutions before was A, D, F. Well, you could just change that by putting A in the middle or A at the end. So for any of the options that we had before, we're going to have 3 times as many now. So the answer of this is 30 times 3, and so there are 90 which include the letter A. So that's a little look at permutations of R objects from N and the permutations function. See you in the next video.